So in this lecture, I want to go through something called conjugation really quick. So conjugation, this refers to the, well, it's really kind of, I'll just call it what it kind of is to be simple at first. This is alternating double bonds within a molecule. And so what I'm saying is kind of double, single, double. It's actually a little bit more than that, but this is a good starting place. So if we look, we would say this is diene and it's conjugated. That's in contrast to a situation where we have dienes next to each other or dienes separated by two single bonds. We would say that these are not conjugated. We need double, single, double. Or, another example of being conjugated is we could have more pi bonds. And then the most famous one is probably benzene. Okay, so this is a conjugated, these are all conjugated systems, alternating double, single, double, single, double. But a better description would be conjugated pi bonds. These are pi bonds that can extend. This is a definition. This is pi bonds that can extend or delocalize across all, quote, conjugated atoms using resonance. Okay, so conjugated pi system is actually a little bit broader. What it's saying is that this is a conjugated molecule because it's alternating double bonds and single bonds. But if we count all of these atoms 1 through 4 make up the conjugated pi system. That is to say, I could actually draw resonance structures that are more than just moving electrons over one space. I could zip the electrons across the ring to give me a resonance structure, whoops, it's not positive, where there's a negative on one side, a positive on the other, and I could kind of go back and forth between those two states. Putting the plus and minus on either side. So I can move the pi electrons across the ring. Okay, so for conjugation, what we're going to start with is thinking about conjugation. If I'm honest with you, we're going to start by thinking about conjugation as, whoops, I can't zoom out anymore, as alternating double bonds and single bonds, like those molecules I showed on the previous slide. So double bond, single bond, double bond, single bond. But that's a good starting place. But we need to build this up into something that's a little bit more thorough, and that is going to account for all of the atoms in the pi system. And so to accurately describe pi systems, we have to think differently about how we handle the orbitals. We're going to rely on something called molecular orbital theory, and that will be the subject of the next lecture. Okay, in a couple lectures. So we'll end there.